Hi friends, welcome to my channel. Today we will discuss about periodic classification. In periodic classification, the main important thing is periodic trends. What is meant by periodic trends? In a periodic table, in periods, the chemical property or physical property of an element is increasing or decreasing, or in groups it is increasing or decreasing, is known as the trends, periodic trends. In these periodic trends, there are so many types of periodic trends that like atomic radius, ionization potential, electron affinity, electronegativity. These like so many periodic trends are there in our periodic classification lesson. In this video, in this lecture, we will discuss about atomic radius. What is meant by atomic radius? Atomic radius is the distance from the center of nucleus to the outermost electron cloud of an atom is known as atomic radius. Now I am writing the definition. Distance from center of nucleus to the outermost electron cloud is known as atomic radius. Okay? Atomic radius is very important characteristic of an element. By regarding atomic radius is mainly depending on screening effect, penetrating effect, and the nuclear charge and the number of cells in an atom. These four we will discuss in this class. Okay. Now we have two atomic radius. I am drawing a diagram of an atom. Okay, first this is the nucleus. The nucleus is positive charge. These are the cells. In cells, the electrons are revolving around the nucleus. Okay, these are the cells. The electrons present in these cells. These like electrons. These electrons from the center. What is the definition of atomic radius? The distance from the center of nucleus. This is center of nucleus. Center of nucleus to the outermost electronic cell, outermost energy level. That means this is the outermost energy level or valency cell. This cell is known as outermost cell. The cell just before the outermost cell is known as the ultimate cell, penultimate cell, and the cell just before to the penultimate cell is anti-penultimate cell. I am writing this also. This is penultimate cell, and the N-2 cell is anti-penultimate cell. Anti-penultimate cell. Okay, the distance from the center of nucleus to the outermost electron energy level is known as atomic radius. This is known as atomic radius, the highlighted part. Okay, I think did you understand the basic definition of an atomic radius? Now we discuss about types of atomic radius. Depends on the nature of bonding. Atomic radius are classified mainly into three types depending on the nature of bonding. Depends on bonds. The first one is covalent radius, and the second one is crystal or metallic radius, and the third one is van der Waals radius. Okay, now first we have to discuss about these three types of radiuses depending on the nature of bonding. First, covalent radius. What is meant by covalent radius? The covalent radius is the radius of a molecule which forms two atoms combine and form the covalent bond. What are the two atoms? One non-metal and another non-metal combine and form the covalent radius, covalent bonds. Crystal radius means the bonds between metals is known as metallic bonds, and the van der Waals radius means it is the weak attraction forces. It is known as van der Waals radius. Okay, first we discuss about covalent radius. What is covalent radius? First you have to know about covalent bond. Covalent bond is formed by mutual sharing of an electrons by non-metal and a non-metal. This is between non-metal to non-metal by mutual sharing of electrons. Okay, first covalent radius. This is nucleus. This is electron. This is an atom, and this is the nucleus of another atom. This is atom. I already said mutual sharing of electrons. In this part, the common electron shared by both two atoms is revolving in this region only. That means the common part. The distance between the covalent radius definition, the distance from one nucleus of an atom to the another nucleus of an atom, half of the distance is known as covalent radius. Now I am explained very deeply. First, the distance between the two nucleus of an atoms is known as internuclear distance. Internuclear distance. This internuclear distance is known as the distance between the two nucleus of an atoms. Two nucleus of two atoms. The covalent radius is shortly written as CR. Covalent radius is equal to half of the internuclear distance, means IND I am writing. Internuclear distance. Covalent radius is equal to half of the internuclear distance. In this way, the covalent radius is decreased by 20% by overlapping on atoms. The covalent radius is decreased by 20% by overlapping of atoms. What is meant by overlapping? Overlapping means upon one atom, the another atom will up with this place. This is known as overlapping. For this overlapping, some place is decreasing. How much percent that radius is decreasing? Decreasing, 20% decreasing. Okay, this is the brief explanation of covalent radius. Next we will discuss about second one, crystal radius. Second one, crystal radius. What is meant by crystal radius? The crystal radius is the bond formed between metal and metal. You know, metals are arranged in a solid form which are very near to each other. We take the atoms touches each other. This is one atom of sodium. This is another atom of sodium, which is just touches at one point. Okay, because the metals are very hard solids. Some metals are weak, that is exceptions. Generally, metals are hard solids, so they are very near to each other. So the scientists assume that the atoms of the metals are very near to each other. That means which touches each other. Suppose you think this is atom of sodium, this is atom of sodium. Okay. The nucleus of sodium here positive, here positive. In this crystal radius also the same definition as the covalent radius, but the distance from the one nucleus of an atom to the another nucleus of an atom is known as internuclear distance, IND. In this crystal radius, CRR, crystal radius I am written as CRR short form. Crystal radius is equal to half of the internuclear distance between the two atoms in a metal sheet or anything metal solid. It is known as the crystal radius. I think did you understand the crystal radius? Next we discuss about van der Waals radius. This van der Waals radius is mainly applicable for the molecules. Okay. Van der Waals radius. Van der Waals radius means this is one molecule and another molecule, this is another molecule. Okay. This is molecule Cl2. This is also Cl2. Now Cl2 is the covalent bond. Cl2 is covalent bond. It has covalent radius. It has covalent radius means the covalent radius of chlorine is some x value, and we have to find what is van der Waals radius. This is the extreme these two atoms which are near in a molecule, different molecules which are near. This is a nucleus of unchlorine atom. This is nucleus of monochlorine atom. These are different molecules. The distance from this chlorine atom nucleus to the center of the chlorine atom nucleus of another chlorine atom is known as internuclear distance. The half of this internuclear distance is known as van der Waals radius. Van der Waals radius is equal to half of the internuclear distance. This is common. Okay. Now, what is the relation between all these three types of bonds or three types of radiuses? Okay, first, one important point is that the van der Waals radius is 40%. Van der Waals radius is 40% more than covalent radius. This is van der Waals radius is 40% more than the covalent radius, because in covalent bonds the atoms are overlapping each other, but in this van der Waals the atoms are so much farther to each other, so the 40% more than the covalent radius. Okay, now the increasing order of the atomic radiuses is van der Waals radius. Van der Waals radius is greater than crystal radius is greater than covalent radius. Covalent radius. This is the relation for the three types of radius. Okay, now we discuss about what is ionic radii. It is very simple definition. What is meant by ionic radius? Ionic radius definition is the distance from the center of nucleus to the outermost cloud of an atom, outermost shell of an atom, of an ion is known as the ionic radius. The same definition as atomic radius. In ionic radius, we take element X. It has some atomic radius. It loses one electron and forms X plus, and it gains one electron X minus. In these three, which has more atomic radius? Now we discuss. This has some number of positive charge. Some positive charge. One electron decreases. Positive charge is constant. Then the effective nuclear charge is increasing. Electrons decreasing, the attracting force is same. There is more attracting force than this neutral atom in cations. When there is more attracting force, the radius is decreases. Compared to radius of neutral atom is greater than radius of cation of a neutral atom. Now we see the anion. In anion, same attractive force, one electron is adding. If the same attracting force means another electron is adding, then the attracting force effective nuclear charge is decreasing. So the atomic size increases. Okay? In these anions, atomic size increases. Radius of neutral atom is less than radius of an anion of a neutral atom. This is the two general terms you have to know in atomic ionic radius. Okay? Mainly, atomic radius depends on mainly three types: nuclear charge, sealing effect, and number of cells. First, we discuss about nuclear charge. How atomic radius depends on the nuclear charge. Nuclear charge means the attraction force. Nuclear charge means the attraction forces which is come from the nucleus towards electrons. When the nuclear charge increases, attraction forces increases. Then the electrons come near to the nucleus. So the atomic radius decreases. Okay? Understand? Nuclear charge. Nuclear charge is inversely proportional to atomic radius. Inversely proportional means if nuclear charge increases, the atomic radius decreases. If nuclear charge decreases, the atomic radius increases. Why I am tell that reason now only. Okay, the second one is screening effect. What is meant by screening effect? Okay, now I am telling generally the screening effect definition. In next video, a separate video for the screening effect I will do. Screening effect means the repulsive forces from inner electrons towards the outer electrons is known as screening effect. Suppose this is a nucleus, first cell, second cell. First cell have 2 electrons, second cell have another 1 electron. Another 1 electron here. Okay, for this electron, attractive forces towards the nucleus is some attractive forces, and the negative charge repels, negative charge, positive charge attracts. They repels, attracts. Okay, 2 electrons are the both negative charge, so they repel each other. This repulsion is known as the sealing effect. The repulsion is known as this sealing effects. When the screening effect, also known as sealing effect. When the sealing effect or screening effect increases, the effective nuclear charge decreases. When the effective nuclear charge decreases, the atomic radius increases. So the screening effect is directly proportional to atomic radius. I am writing the relation. Screening effect is directly proportional to atomic radius. If the screening effect increases, the attraction from the nucleus also decreases. So the atomic radius increases. Then the third one is number of cells. It is very easy. Suppose this is nucleus, first cell, second cell, and third cell. For the attraction from the nucleus in first cell electron, in first cell number of some electrons are there, then the atomic size is less because the attraction force is more. For just it is nearer to the nucleus. For first cell, the electrons are very near to the nucleus. Distance is very less, so the attraction forces is very more. Then we go to second cell. Second cell, some electrons is there. That electrons is more distance compared to the first cell. So they experience some less attraction forces than the first cell. This means when the number of cells increasing, attractive forces decreases. Attractive forces decreases, the atomic size increases. So number of cells is directly proportional to atomic radius or atomic size. For the third cell you take, it is more distance compared to the second cell. It experiences less attractive forces than the second cell. So it is more size, more atomic radius than the first or second cell. Okay, this is the main 3 reasons for the atomic radius. These atomic radius in groups and periods, how it will increase or decrease. First, I will see in periods. In periods from left to right, the elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This like some elements are there in periods. For lithium, how many electrons in lithium? 3. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. It is an octet configuration for the noble gas elements. First we take 2, 1. 2, 1 means first cell filled, second cell only 1 electron. Only 1 electron means it has some atomic mass. In this beryllium 2, 2, 1 electron increases and another proton also increases. Now I am telling how the in periods atomic size decreases. You got some doubt. The number of electrons in the cells are increasing, so the atomic size also increases. Why the atomic size is decreases? Now I will see the clarification. The mass of electron is equal to 1/1837 times the mass of protons. So in lithium 2, 1, beryllium 2, 2. In this, number of protons is 3. In this, number of protons is 4. One electron increases and another proton increases. Then the one electron increases means there is small change in mass of an atom. And the one proton increases means there are 1837 times increase in the mass of the electron. So the attractive forces is very more than compared to the lithium. So the beryllium attractive forces are very more, so its size is very less. In this way, in periods, the atomic size is decreasing. In next video, we will discuss about screening effect. Screening effect. This screening effect is very important, and the Slatter's rules. How did you find the effective nuclear charge of an atom? Okay, thanks for watching this video. Please subscribe.